Now we're going to take a look at some properties of summations to see how we can make the summation process a little bit easier to do. So the first two are written right here. And it says, when I have a summation from k going to 1 to any integer n, if I have a constant c times my variable k, I can pull that constant out in front. So I can factor out the c. So let's take a look at an example of that. We're going to do a summation from k equals 1 to 4 of 2k. Now, if I were going to write all of this out, that would be 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4, which isn't terribly hard to do. And that would give me a grand total of 20. However, if there were a lot more terms in this summation, using the shortcut would be beneficial. So the other way to do this is to say, all right, that is 2 times the summation from k equals 1 to 4 of k, which would just be 2 times 1 plus 2 plus 3 plus 4, which gets me to the same final answer of 20. So again, this trick could be really helpful if we had a long summation to do. The second property says if you have a sum or difference inside of a summation, you can split this into the sum or difference of 2 or more summations. So just take a minute to make sure you copy that down. When we do some examples later, you'll be able to see how it's used. There are 4 different formulas that you need to know when using summations. It's important to note that in order to use the formula, the lower limit must be a 1. If it's anything else, you would have to do what's called re-indexing of the summation and change it so that you don't have a summation starting with a number other than 1. You have to make it start with a 1. But we're not going to worry about that at this point in time. So the summation for k equals 1 to n for just the letter k is equal to n times n plus 1 divided by 2. So that's our first formula. An example of this would be a summation from k equals 1 to 5 of just k. The answer here should come out to about 15. Let's see if we can do it using the formula, though. Here, I'm just going to write down that our n is equal to 5. So I'm going to do 5 times 5 plus 1 all over 2. So that's 30 divided by 2, which is in fact 15. That's the same as if I was going to do 1 plus 2 plus 3 plus 4 plus 5, which is what the original summation says. But if that number n at the top had been a lot larger, this formula can make the process a lot faster. Okay, the second formula. Remember, c is a constant. So the summation of a constant is just a constant times the number of numbers you're going to have. So it's just c times n. Here's an example to make this make a little bit more sense. If I was going to do the summation of 7 from k equals 1 to 4, that would be 7 plus 7 plus 7 plus 7, which comes out to 28. Because k equals 1 would give me just a 7. There's nowhere to put in the k equals 1. Since we're going from 1 to 4, that means we're going to have 4 terms, 4 sevens. The faster way to do it using the formula is to say, okay, take the constant, multiply it by n, and that gets you to your 28. So there are our first two formulas. The next one is for if we are going to do summation of a variable squared, k squared. That formula is n times n plus 1 times 2n plus 1 all divided by 6. Which seems complicated, but it's always guaranteed to be divisible by 6, so you work out getting an integer. So for our example, we're going to do the summation of k squared from k equals 1 to 6. So our n here is 6. So I'm going to do 6 times n plus 1. 6 plus 1 is 7. And the next number will be 2 times 6 is 12 plus 1 is 13. All divided by 6. Now, one way or another, you should be able to reduce, in this case, simply those two 6's to end up with a final answer of 7 times 13, which is 91. If you wrote out 1 squared plus 2 squared all the way to plus 6 squared, you're going to get 91. Our final formula is for k cubed. The formula for k cubed has brackets, n times n plus 1 over 2, close the brackets, quantity squared. So it looks similar to the k formula, but the whole thing gets squared. So here's our example for k cubed. The answer to this would be 1 cubed plus 2 cubed plus 3 cubed, which comes to a grand total of 36. Using the formula, and n equals 3, I'm going to do 3 times 4 divided by 2, and I'm going to square it. Remember, order of operations start with what's inside the parentheses first. So I'm going to have 12 divided by 2 is 6, square it to get 36, which is the same answer I would get if I just did the three terms out. It would have been 1 plus 8 plus 27, which is 36. I'm going to give you two problems to try on your own. So take a minute, write this problem down, and see if you can find the value of the sum using the formulas. Keep in mind that since there is addition here, you can do the summation for k squared, get an answer, do the summation for 3k, get an answer, and then add them together. So here's what I came up with. I start with the summation from k equals 1 to 4 of k squared, and I got an answer for that. The formula for k squared says do n times n plus 1 times 2n plus 1 all over 6. Now I can't easily divide by 6 here, but I can do some reducing. For example, I can do each of those divided by 2 to get a 2 and a 3, and then I can reduce again this and this to get a 1 and a 3. So my final answer here comes to 2 times 5 times 3, which is 30. Now I'm going to do the summation from k equals 1 to 4 of 3k. Remember, I can pull the 3 out in front, and then just do the summation of k. So that's going to be 3 times the summation for k, using n is 4 times 5 divided by 2. And that's 20 divided by 2 is 10. 10 times 3 is another 30. So if I take these two answers and add them together, I should get a final summation of 60. Alright, one more problem for you to try. Take a minute, copy this down, then pause the video to try to get an answer for yourself. Alright, the first thing I'm going to do is I'm going to distribute the I, because there's no rule that says when I have a variable times something else that I can factor it out. So, I'm going to write summation from I equals 1 to 15, and this is going to become I cubed minus 4i. Okay, so if I start with the summation from I equals 1 to 15, and if I just do I cubed, remember, I is the same thing as k. It doesn't matter what letter you have as long as they're consistent. The formula says to do brackets n times n plus 1 and divided by 2, square the whole thing. So let's see. The number inside here, oh, sorry, forgot to write the squared. Squared the whole thing. So I'm going to do 15 times 16 divided by 2 in the square. That comes out to 14,400, or 120 squared. The second part, summation from I equals 1 to 15 of negative 4i. Actually, you know what? We can ignore the negative for now. And just remember that we need to subtract our two answers. 4i. So that's going to be 4 times the summation for just I, which is 15 times 16 divided by 2. So this is 4 times 120, which is 480. Since there was subtraction between the two, I'm going to subtract to get my final answer of 13,920. All right, I hope these examples were clear.